Hello everyone, we welcome you to Glass Academy Webinars 2023. The theme for this year is Art and Science of Designing Responsibly. Today we have with us architect Ar.Anupama Mohanram, an architect with a passion for environmental sustainability. Architect Anupama has done her PR from School of Architecture and Planning, Chennai, and holds a master's degree in architecture from Kansas State University, USA. During her 10-year practice in Chicago, she was involved in the design of multiple projects, including schools, offices, residences, and banks. Architect Anupama's interest in nature and green technologies spurred her to obtain a LEED AP accreditation before moving back to India to start her own architectural firm, Green Evolution, in 2008. She leverages her rich international experience in environmentally sustainable architecture to design and construct green buildings in the Indian context. Architect Anupama is also a featured writer for The Hindu and has authored over 60 articles on environmentally sustainable building practices in her column called Earthright. Some of her recent awards include HUDCO Design Award for Best Green Building Design, the School KFI Chennai, and Construction Academy Award for the Best Green Building Design and Construction, Palmyra, Chennai. Welcome, Architect Anupama. We are delighted to have you here with us today, and we are looking forward to your presentation. Let's hear you on the topic, Glass in Green Buildings, a Window to a Better World. Over to you.
Thank you so much for that introduction, Anvita. And yeah, good afternoon, everybody. So I'll go ahead and get started right away. So today I'm going to talk to you about glass in green buildings. So to begin with, I do want to introduce glass, in context. Now, architectural glass, we know, is a great material, right? I mean, it allows us to connect with the world outside. It allows us to stay inside, prevents the dust and the heat and the dirt coming in, but then allows us to get a visual of the exterior world, and also brings in natural light, right? So it's a wonderful material today. But the biggest disadvantage of glass is it also brings in a lot of heat along with the light, right? And when compared to materials like brick, it actually brings in double the amount of heat. So that is an issue. So when we look at that, especially in places like, Chennai, which is like a hot and humid place, that amount of heat results in excessive air conditioning. So how can we use this material, this wonderful architectural glass, but prevent the typically brings it? Right. So today I'm going to talk about a few strategies that we could consider when we design our buildings. I've divided it into two parts. Okay, the first strategy that I look at the passive design strategies, right? So designing that gets into the building. So the first step, like here, if you look at passive design strategies, is you ensure sensible and judicious use of glazing. So what is that? Basically, you orient the building in such a way that it is like, for example, in Chennai, not much of east and western exposure should be covered by glass, right? And you should also know how much glass you're using in a hot and humid place like Chennai. And then, of course, you need to make sure that the glass, how much of a glass you use, is adequately shaded. So if you have sunshades for glass, that's what will cut out the direct heat gain. So these are all passive strategies. A lot of it depends on the site, right? Let's say you have, in your site, you have a very tall building on the east. Now that's going to cut out all of the heat and the light also that comes in from the east. So you can actually use more glass on the east. So everything is relevant to the context. So that's what happens in the initial stages of architectural design, right? See where your site is, and make sure your building is oriented to the right direction to prevent a lot of heat gain from coming in, and also see what's surrounding, right? And of course, ensure there are trees. So all that will help prevent the heat gain through glass. So the second strategy I'm looking at, so once you've ensured the building is, designed to, you've done everything to ensure by way of, locating the building, or, by way of ensuring how much glass you've used. Once you've done that and tried to prevent as much of the heat as you could, then you move on to what is the type of glass. right? So today's technology, there are a lot of different glass types that are available. Companies like Saint-Gobain have high performance glass that gives us the option to use glazing that would prevent the heat but let in the light. So these are all new technologies. So if you look at the glass type, there are basically two types of glass. Like a broader category. One is an insulating glass. So insulating glass, insulation is the amount of heat that the glass would prevent from entering into the building, right? So if you want to use glass that is insulating, you need to ensure it is either a double glazed system or a triple glazed system. Which means a double glazed system is, there are two panes of glass with air pocket inside in the middle. So that doesn't, the air particles would dissipate the amount of heat. And triple glazed is like you have three panes of glass with air cavities between each pane. So you could look at in glass that is insulating. And the other type of glass you could look at is solar control glass, right? So solar control glass is basically glass that has been treated with coatings, right? And what we call a low emissivity coating. Basically, that actually prevents the amount of heat from coming. So these are coatings that are made of, ceramic coatings. And right now, silver and nano coatings are very popular in glass. So the glass goes through a process where it's treated with these coatings, and which reduces the heat gain from coming. And today, when we look at it for building designs, there is a lot of options for, different kinds of glass with different kinds of heat gain that it lets in. And also the visible light that comes in. And different colors, right? So as an architect, if I'm looking for, let's say, 20 years ago, we would not have all these options. So the glass options are also, getting better and better. So when you pick the type of glass, right? So I talked about insulating glass and I talked about heat control glass. So what are the factors? So I've kind of located my building and now I've kind of determined what the window sizes are. Now I need to pick the glass. So what are the factors that I would look at when I pick a glass? So there's a factor called SHGC, right? Which is the solar heat gain coefficient. So basically, a solar heat gain is a coefficient is, if it is lower, then the heat gain is lower. Basically, it's the amount of heat that the glass allows to enter into the building. So the value SHGC is something that we have to be very selective of. And the lower the SHGC, the lower the heat gain. The next factor that we look at, of course, is the U value. U value is the amount of heat the glass will actually reflect, in the sense it would insulate, it would not let into the, right? So SHGC is the amount of heat that comes into the building, and U value is the amount of heat the glass will prevent from getting into the building. So again, the lower the U value, the better the insulation. It insulates the building from the heat outside. So SHGC, U value. And then the third factor we look at is what's the point of having glass and not, having natural light inside? If there's not enough natural light, then we end up not a very environmentally sensitive option. So be a glass that also has a higher VLT, visible light transmittance. So the higher the VLT, the higher the light transmittance. It's a bit of a, balancing act, because some of these coatings, that would prevent the amount of heat from coming in, also prevent the light from coming in. So you have to balance out the SHGC, U value, and the VLT. So you're kind of getting an optimum visible light and also getting somewhat of a low heat gain into the building. And the fourth factor we look at, of course, is the color, right? So once you decide any of the, it depends on what the aesthetic of your architectural design is. So right now there are blues, greens, neutrals, grays. So the color is what, again, the color also influences the values a little bit. So the different colors will have slightly different SHGC and the VLT. So these are the 4 factors that you need to look at when you actually select your glass. So that was a brief introduction on glass itself, what we should look for, how we should start off with, designing to ensure that the glass that you use does not bring in as much heat, but also lets in light. Right. So now I'm going to talk about a couple of our case studies just to explain things like, the factors that I mentioned to you earlier, how we went about, looking at the passive design strategies and picking the glass. So this first project is an IT building. It is in Guindy in Chennai. The name of the project is the Palmyra. And we completed this building last year, 2022. It is about 11,500 square feet building. The site area is 11,500. The built-up area is about 28,000 square feet. It is a still plus a 4-floor IT building. So this building was awarded the LEED Gold certification in March early this year. We also won the best green building design for this building. So just some overall facts on the building. Very highly energy, water and resource efficient. And we looked at occupant health and well-being, right? Because that's very important. Indoor air quality, indoor light ventilation. And people have to be comfortable, right? I mean, that is the ultimate of design, building design, right? We all spend about 90% of our time indoors. So even when when you're using glass, you need to be conscious of the fact that you don't want to let in too much heat because people will be uncomfortable, right? So it's finally comes down to occupant health. So this one was designed with occupant health in mind. And then you notice the striking aesthetics here, which we are very conscious about. So you must have seen all of these glass buildings in Chennai. Some of them, to me, is just a mimicry of buildings in the West, right? When I look at old Mahabalipuram Road, when you're driving in Chennai, especially, there are all these glass facade IT buildings facing east and west. Can you make it a little more grounded to the place? Can it be, like a contemporary design, but yet, that looks like it's rooted in place and time. So, be a little bit more conscious about the facade and the design aesthetics also. So this building, just to give you a little bit of a background, the client's requirements included a lot of glazing. And like I said, we wanted it to be very unique and different. And the second thing that they were looking at is it should comply with relevant green building standards and it should achieve a green building certification. So for us here, the challenge was to use adequate glazing to bring in views to the outside, and also ensure there's adequate natural light and ventilation, but yet restrict the amount of heat that is coming into the building. And to reduce, of course, energy consumption. And we wanted to ensure, like I said, a very comfortable workspace for the occupants. So what did we do here? Thankfully for us, the site was a rectangle and the longer sides faced north and south. So in Chennai, the first thing that we do is, most of the heat comes from the east and west. So if you can shield the east and the west from direct heat, then it becomes you have like a better chance of making the building cooler. So if you look at this building, the way we structured the building or oriented it on site, we used the east facade for the lobby and the lift, and the west facade was the toilets and a staircase. So the workspace in the center had north-south glazing, which in itself, so we were able to eliminate a lot of the heat coming in from the east and west by orienting. So this building south, this faces north. So, we're getting we were able to get air circulation, cross ventilation into the building with the breezeways from the south. Um, so that way, we could actually use a lot of glass. We in this building, we used about, if you look at the north and south facades, 50% of the facade is actually glazing. So the first step was orientation. The second step, once we had oriented the building in the right direction, the second step was to make sure that, all the glass that we used, like I said, because 50% was glass. You see these yellow rectangles there, that's the glazing. So we needed to make sure that the glazing was adequately shaded. If you look here, the glazing starts at 2 feet of sill and goes all the way up to 10 feet. So it's actually a very tall window, and it's very wide also. If you look, this is about 15 feet wide. So there is a lot of glazing in this building, but we also ensured that there is a lot of the direct heat from falling on the glass, right? And also the glare that the sunlight would bring in. So this is the shading that we have used here. And every now and then we have these projections. So that gave us the vertical shading also, right? So it's not only the horizontal projections, but also vertically it's boxed in. So there is a lot of shading that's happening, yet because of the width of the glass, there's a lot of light that comes in without the glare. And these that you see here on every floor, right here in this section, those are all planters. So we also wanted to ensure, when you look out of glass, when you're in a higher level, it's important we feel that people need to connect to nature, right? So we do a lot of planters on the facades of our building. And that also ensures, the glass is kept cool. It's usually creepers that we do here. So that way, it's a nice view for the occupants from inside, and also somewhat of a shading for the glass that it provides. So it's like a little buffer that you see here. So through this sunshade and these boxing outs that we did, you can see the box out here, these gray boxes. So those are actually wardrobes. So they could functionally use it from inside as wardrobes, but also, ends up providing. I also wanted to mention that 50% of this glass windows are operable glass. So if you look at a lot of the IT buildings, they have fixed glazing, right? That's something that we don't do, because you need to ensure that there is some amount of natural ventilation. Let's say one day the air conditioning doesn't work. A cyclone like this that happened, it's obviously something that you can't control, and you're stuck inside if it's fixed glass. Right? So we always ensure most of our glass is operable. So even if they want to run the air conditioning, considering it's an IT building, we are giving them the option to open out at least 50% of the windows. Right? So that gives them the flexibility. Let's say somebody, in one floor doesn't want to run the air conditioning. So if we didn't give them that, then it's going to be very hot and constrained, and there's no other option but to, crank up the air conditioning. So a strategy would be to ensure that, at least 50% of your windows are operable. So when you look at shading, we talked about sunshades, we talked about vertical masses that, would prevent the heat from coming in. Another type of shading that we use a lot in our buildings are jalis. Jalis are actually a very traditional feature. In this building, we customized a jali, like with a leaf pattern. So it becomes a unique identity for the building. And also what it does, like this jali is in front of the glass. So it again acts as a shading element, right? And not only a shading element, it forms interesting shadow patterns. There's a lot of light shadow play. Again, makes the space actually inspire people. It should, be a space that you're happy to go to and observe, different features rather than it being very bland. So these jalis are a very effective way to shade glass. It brings in the filtered light and also the filtered heat. and also ends up forming different patterns. In this case, these are metal jalis that we use, but you can customize it to any design. So it's a very interesting aesthetic feature that also acts as a shading element for your glass. So if you look at this building, some statistics then, like I told you, the north and south facades, the WWR is 0.5. WWR is the wall to window ratio, right? Window to wall ratio. So the 50% of the wall is windows in this case. So we picked a glass called Icy Menthol. It is in a Saint-Gobain series called the KT series. So it's made of a coating that is a nano silver coating. And we picked a glass that's a neutral and gray tint. If you look at the facade, we wanted a glass that is a little grayish or neutral to go with our scheme of the dark gray and the exposed brick that we were using on the facade. So we decided on that. And this icy menthol glass had a visible light transmission of 37%. And a solar heat gain coefficient was 0.29. So this is the glass that we decided to pick, and it's in a DGU, which means it's got it's a double glazed unit. So it's got two panes of glass, 6 mm and a 12 mm air gap, another 6 mm glass, right? So if you look at this statistics, what's interesting here is although the solar heat gain coefficient of the glass itself is 0.29, after considering all the shading that we did, right, all of the projections and the vertical masses, the SHGC came to 0.1. So it's like, it's reduced the amount of heat coming into the glass. Let's say if we didn't have the shading, the SHGC would still stay at 0.29. So with your design elements, with your aesthetic elements, you can actually do a lot. So 0.1 means that only 10% of the heat gain is actually coming into the building through the glass, right? So, and then you ensure with shading, you are able to reduce the heat gain even more. So this is just a conclusion slide for this project. So we looked at, just to give you a little bit more details about this building. The walls are all made of AAC aerated concrete blocks, which actually is very, very insulating. So it's already, the walls reduce a lot of the heat from coming in. And the heat resistant double glazed windows that we're doing, adequate shading. We have a 60 kilowatt rooftop solar photovoltaic system on top, which takes care of a lot of their energy needs. We have installed automatic sensors to control all the equipment, daylight sensors. So that way your energy is also very optimized in this case. Water conservation was a big part of what we do usually. So sensor controlled water fixtures, on-site wastewater treatment. So we ensure that all the wastewater is treated and is reused. In this case, it's reused for landscaping and for the flushing. So we have another water tank on the rooftop that is a flush water tank. All of the rainwater that falls on the roof is 100% harvested. So the idea is not to it's a zero waste water discharge site, which means we try to harvest all the water that falls in the site itself. Either we collect it and reuse it, or the rainwater that falls on the roof is actually collected into the sump and reused, or it's percolated into the ground. And the planters, like the planters I had mentioned, they have an automatic drip irrigation system. That is actually the irrigation for the planters comes from the gray water, wastewater treatment, treated water. So, and that provides a green envelope for the building. And of course, occupant well-being, which is a lot of natural light, ventilation, and other factors like universal access. So yeah, starting from the glass, it's the overall, the holistic health, environmental health of the building that you also need to look at and understand, when you do the design. It's not only, you pick the glass and leave. You need to understand what other factors work. Like I talked about sensors, timers, daylight sensors. So all of that, which will end up reducing your energy consumption. So these are just some slides that I have, some photographs of the project. This is the east facade on the left here. Okay. So the second case study that I'm going to talk about is the Integrated Central Command and Control Center. This building is a government building, and we designed this for the Greater Chennai Corporation. This is actually a central command center for the city of Chennai. So all of the services in Chennai, like the traffic, the police, everything is going to culminate here. So there is a huge double screen video screen space. So all of these services sit inside and they observe everything that's happening in Chennai. Let's say for the rain, the cyclone ravaged area. So they would get the information on screen, what is happening where. So the people would be like, clued into where to take, action. So this is command center. It's actually just behind the Ripon building. If you know Chennai, there's a heritage building called the Ripon building that is here, which is the headquarters of the Greater Chennai Corporation. This is our new building. So it's coming up just behind the Ripon building. So here, it's about 90% complete. It will be fully complete by end of this year. It's a 60,000 square feet building. It built on a 30,000 square feet site. Again, it's a stilt plus 4 floors, very similar to my previous case study. And it is an IT building in the sense. So it's all offices. So earlier, just a couple of weeks back, this building was awarded as the greenest government building in India by the Indian Green Building Council, Platinum Green New Building certification for this building. So this happened in the Green Building Congress just a couple of weeks ago. And it's also, the building is targeting a LEED certification. So we want to ensure it actually receives all of the certification possible. Some of the key features, like all our projects, it's designed to be highly energy, water, and resource efficient. And other factor is the striking aesthetics. So if you see the previous case study, and it's also that is the function of this building, right? It's a very high-tech IT kind of use. But if you look at the aesthetics, it is very too much from the Ripon building here. It's very important buildings, and we make sure that our design, is in context of that. It can't just stand as an isolated structure. Right? So that was an important part of what we do. Again, they wanted it to be a very modern building with a lot of glazing. And of course, they wanted it to be as green as possible. And they wanted the highest possible LEED and IGBC rating for this building. So again, the same challenge here, right? So very similar to the Palmyra. How do we do this? We need to look at glass with low heat gain. How are we going to match the aesthetics with the amount of glass that we're using? And how do we, of course, reduce the energy loads? So this is the floor plan of the building. So if you look at this, the primary, again, glazing, there is a tall building right on this side, which is the east side. And on the west side, there is a road right here. So we wanted to ensure, again, the north. This is the north and the south sides. And this is the west. So there's a row of trees on the west, which we retained because the west is where most of the heat comes in. Again, why is it important to look at the site? If the trees, it's an open field, it's, getting a lot of radiation, I would be judicious about using glass there. So it's, a lot of it also depends on your site. So in this case, we, although we used a lot of glass again, it is actually more than 50%. This is the services part. There is not enough light coming in the center of this building. So we have a courtyard that is cut out in the center. So we do a lot of daylight simulations to see, what is the light, because we wanted the building to be well lit from inside, especially in the primary workspaces. So this courtyard has a BIPV roof on top. So that lets in, adequate light again, but also, screens off the heat. and ensures that this workspace surrounding the courtyard is also well lit. So again, the same similar strategies like I mentioned earlier. And here, if you look at the first strategy, like I said, is shading, right? So in this case, we have roof overhangs that is happening, which is the horizontal shading. But unlike Palmyra, the previous project, we also have vertical fins that happen, right? So it's not only horizontal shading. So this is the glass that you see here, but it's broken by these vertical fins. And as it goes higher, there's more light that comes in. So and more of the heat also that comes in. So because there are a lot of trees up to this level. So we decided to increase the number of fins on the top floor. So if you look at this, there is a lot of glass, the image on the right bottom, but it's broken by these fins and it is well shaded. So it's bringing in the light, but not the heat. And this arch also, again, was a factor in design, right? When we designed the windows, we wanted the arches to kind of simulate, like the Ripon building that was right next door. So it has a little bit of the traditional, the cultural context right there. And similar to the Palmyra, again, we have planters on alternate floors here. So the second and the fourth floors have planters, and that would have a automatic drip irrigation system. So this is another view of the building. You see some of these trees on the west that I was talking about. So again, our window wall ratio was 0.5, which means about 50% of the glass, 50% of the wall is actually glass in this case. We picked the same glass as we did for Palmyra, because again, we wanted the same neutral tint, and the BLT and the SHGC kind of helped us with the lighting and, even for this space. So we use the same Saint-Gobain IC menthol, like 80 sees the heat gain that comes in. GC is 0.29 SHGC of the glass. But when we considered the shading in this case, east and west facade, the SHGC went down to 0.15, which means it's letting in only 15% of the heat. So from 0.29, just because of the shading, you see how much it is actually cut down. But what was interesting is in the north and south facade, SHGC went to 0 because of the vertical fins that we have done. So there's no heat gain coming in, and the visible light transmittance was if we didn't do the vertical 1 to 0. So again, in this case, it ensures a lot of natural light without the heat into the workspaces. So this is another image of the building from a corner. All these vertical features that we did, it's an aesthetic feature, but it also, again, is functional because it offers shading to the building. Like, let's say if we didn't have it, it would be one continuous layer of glass, right? And that would only end up bringing in the heat. So like I said, it's an aesthetics that complements the Ripon building style of architecture, but in a very simplified and a very contemporary way. Also uses a lot of glass. It is a modern glass building, I would say. I just want to, conclude by saying, if you look at the past, the 2 case studies, I guess my point would be, can we use glazing in our buildings by taking advantage of its features? But at the same time, can we bring in also design elements, right? That would enhance the charm of glass. So if you look at this building versus like I said, a straight facade, I mean, it is actually something that makes you think, right? It's charming. And it enhances like I said, the glass itself. And also a big part of what you should all consider is, of course, we need to use glass, but we need to ensure that you are able to cut down the heat gain and the glare that comes in. But also, can you use it in a way that the buildings stand relevant to our context, stay rooted in our context, and pass down the culture to future generations, right? So that is the future of glass. So if you can bring out the context of where you're building, and but yet use the technologies that are there today, right? And to design buildings that so thank you very much, and so over to you, Anita.
Hi, ma'am. Thank you so much for shining light on the importance of glass in green buildings through your presentation. Your thoughtful exploration of the role of glass in creating environmentally
Sure.
conscious yet aesthetic spaces, as evidenced by the examples from your projects, have provided valuable insights that undoubtedly enriched our viewers' understanding about the role of architecture in fostering a greener world. We have a lot of learnings to take away today, but we're also curious to know more. So I would like to take this opportunity to ask you a few questions.
Sure.
So to begin with, the term green building is often used, but not completely understood by many in the design community. So as an expert, how do you define the concept of green building and what are some common misconceptions people have about the green building?
Well, to define a green building, I would say it's a building that's been planned and designed with the environment in mind, right? With the environment and occupant health in mind. So there are two things here. Green building would not only minimize the destruction to our environment, but also ensure the occupants are healthy inside the building. So these are the two big points. So when you look at green building, there are like, starting from the site context, we would ensure that we preserve any existing trees on site because that's what makes the surroundings cool, right? I mean, today urban development is mindless, I would say. The first thing people do when they build, they just go clear the site of all the trees and the vegetation. So now they have a clean slate to play with. But that's not the way. I mean, we all know climate change is real, right? So that is not the way to design a green building, right? The first step is to ensure, okay, what are the trees? Can I leave these trees? Because that's going to give me oxygen. That's going to, help cool the place. And can be designed with the trees in mind. And I feel that's also makes it very challenging. And we love challenges, right? I mean, that's what architecture is about. If you just have a clean slate, you can do anything you want. But with if you can design around existing vegetation, that's when you are challenged enough to use your brain and to come up with something interesting. So with a green building, I would say that's conscious of the site itself, the vegetation on site, and it doesn't consume and it minimizes, right, all inside the building, and used sensibly. All the wastewater that we let out is treated and reused. So a lot of it is so energy waste, wastewater, and also the waste that we generate. So it's a building that's designed adequately. So all the waste is uh, either like treated and reused, or it's disposed of in a very sensitive manner. So being an architect, you should be aware of all these things. So that is what a green building is. So how can you do all of this? And also ensure the occupants. So kind of materials that we use, like the paints that we use are all natural paints, low VOC paints, as we call them, non-toxic paints. Um, and some of the features, that we use natural flooring. We don't use materials that have high embodied energy, which means in the manufacture of some materials, there's a lot of pollution, right? So I would use materials very consciously. I would manage my resources very consciously. So if you look at natural materials, if you can't do natural materials, then look at materials that don't have a lot of pollution in manufacture. Can you minimize those things? And first step is to even minimize material use. So a lot of our buildings, we leave it as open brick. We don't plaster, outside. So that saves us material and therefore saves the pollution from the manufacture of new material. We also use salvage materials. There are a lot of materials from demolition sites that are thrown out right now, and people are starting to repurpose them, salvage them, and that's all good quality wood and steel. So we should start considering, use of salvage materials, because ultimately at some point not going to be enough natural resources left to keep on making new materials, right? So all of that is what a green building is about. In a sense, what are the misconceptions with the green building? Initially, when we started in 2008, cost was a big factor, right? So when we talk about green buildings, people would say, oh, that's too expensive. Without understanding the life cycle cost, right? So maybe, like to do a solar power, because of course, like I said, a green building would also have enough technology in it, right? So the additional cost is the technology. But the thing is, all this would lead to life cycle cost savings, right? So the cost was a big factor initially, but without understanding that that year after year they're going to save on their electricity bills or water bills. So that is one misconception when people come to us, and we have to educate them and tell them it's going to be lifetime worth of cost savings for you because we're doing all these things. So green building actually results in a lot of cost savings. And cost of technology is coming down, which is a good thing. So initial investment in solar, wastewater technologies, with all the demand and the competition has come down quite a bit. So that was one conception that was there earlier. Um, so the other one actually was the sometimes the other extreme, and then people would come to us and say, so is green building natural? That should it be less expensive, right? So I have a budget. The way like look at thatch in the urban environment. There's only 2 thatchers in Tamil Nadu right now. So where do you go for the skill, right? Unless people ask for more, demand more of the natural material. So those are also a little more expensive than what people initially think of. So I guess cost is the only thing that I'm seeing, and it's two extremes right now is where we are looking at. So yeah.
Right, ma'am. Yes. So this brings to my second question. So glass technology, like you mentioned, is constantly evolving. So we get new things every day in the market. So are there any recent innovations or advancements in glass materials that you particularly find exciting for the future of green buildings in particular?
Yeah, as you said, yeah, glass technology is constantly being improved upon. Saint Gobain was one of the leading high-performance glass manufacturers right now, and it's interesting to see, like, let's say in these 2 buildings, we've used a series called KT series. It's the kind of coatings that they process on glass, right? That helps us reduce the amount of heat coming in. So these coatings were not there; it would be like really like an oven inside. So the coatings are getting better and better. These are all nano coatings. So the nano particles are getting, the particles are getting smaller and smaller. They have technology to make it better. So now they've come up with, after these 2 buildings, there's even more of a higher performance glass now that has 2 layers of the silver coating. Right? This has 1 layer of the coating. That series has 2 layers of the coating. So they're experimenting with things like that, and how much of SHGC would that reduce? Right? And in the residential sector also, they've come up with, so there is a single layer glass that we use in most residences because it's not a commercial building. They're not going to air condition it all the time. So that technology, again, is coatings that reduces the heat. But they're also increasing the efficiency of the coating so that it would let in much more visible light. And also I think one of the recent innovations is just a couple of years old, where they've reduced the amount of reflection of the glass from
Right.
inside. Because when you put the coating, becomes a reflective glass. So how can you get it better and better to reduce the reflectivity from inside? So we're finding that very interesting. So you get a clear view from inside. So that is the newest technology in glass. But yeah, it's getting better and better.
Yes, ma'am, totally. So your projects comprise a wide range of building typologies from public buildings to residential to offices, etc. So do the parameters of selecting a glass to help achieve green building design vary from different typologies, like the design thought process or the selection or the amount of glass to be used or anything like that? So could you please elaborate on the same?
Overall, they don't actually, because we look at the same strategies. We start with the how is the building located on site? What are the surroundings of the building? And how are we going to shade it? So these 2 things are very common for any building, and especially I'm talking about hot and humid, in South India. So you're looking at adequate shading and orientation. So you prevent the direct heat gain from coming in. Whichever way in your city, if you find a lot of heat gain in summer is from one direction, I would close off that. Like I said, I would put my toilets there or wardrobes there and not do as much of glass there. So the passive strategies are the same. The selection where they would differ is most of the commercial buildings people ask for air conditioning. that's a given these days. So we try to reduce it by saying, if you look at this building itself, it's openable windows, right? I mean, we say, no, we will plan for openable windows. You don't need to open it. If you give them that flexibility, then a lot of people actually tell us that they like to open out the windows, right? So at times like November, December, there's no need to close it off and run the air conditioning. So, but in a residential case, because it's planned as a naturally ventilated. So we would ensure everything is openable. We would not have any fixed glass, as we don't do any fixed glass in a residential building because it just ends up bringing in a lot of heat and makes the space uncomfortable. So I think
Right.
that's the difference. In an IT building, we would probably say, okay, 50% like Palmyra, 50% of the glass can be fixed, fine. But at least, 50% have to be openable. But in a residential building, we would keep it 100% openable. But everything else, and the type of glass, a lot of it is cost. So residential buildings, it's very cost prohibitive to use these kind of the KT series or, double glass unit. It's also not required because they're not going to run the air conditioning. So we would use a single pane glass, right? With the same coating, but it's a single pane. But in a commercial building, we always use at least a double glazed unit. So
Yes, ma'am, definitely. So this brings me to the last question. Thank you for taking so much time and patiently answering them all, ma'am. So given the increasing emphasis on sustainable
sure.
practices, what advice would you give aspiring architects who want to specialize in green building design?
I would say, first make sure you design to context. You look at green buildings as how, if you look at India, for example, there's a lot of traditional buildings that are green. And now we are going back to that, right? I mean, if you look at Tamil Nadu, sunshades, the concept of sunshades disappeared in 2000s. So the kind of architects that were designing buildings, you would see facades of glass, which is just an imitation of the West, right? And there are no sunshades. So which ends up bringing in a lot of heat. The context, look into your culture, or we would do glass on top with a top hung window that has a way for the hot air to go out. So ensure that your designs are to context and designs are unique. And of course, ensure that, like all of the strategies that I mentioned, right? Whatever, if glass is, I said, a wonderful material. So if you use glass, ensure that you use it sensibly and very judiciously in the right direction, in the right sizing and the right type of glass, right? And definitely make use of all the technologies that are there today. I'm sure with AI, there's going to be many more such technologies that we're going to, have to face. But make sure you don't lose your, what would I say, like your unique design abilities, right? So you have to stand out and ensure that you're using the right materials in the right way. And of course, not ignoring the environment, but make sure that you're doing something that would stand for the future generations, right? That will make an impact.
Absolutely well put, ma'am. And this brings us to the end of this informative and insightful session. So on behalf of all of us at Glass Academy and Ethos, I'd like to thank you for making time today and sharing
Sure.
your thoughts with us, ma'am. Thank you so much.
You're welcome. Thank you so much.